Hello, I would like to share with you some of our works about economics and market constructs for the future power systems. It is particularly tailored for the future power systems where there is a significant amount of clean renewable resources, many of which are distributed into the edge of the grid, and a lot of the consumers who can both consume as well as contribute energy to the grid. The overarching question is really at the wholesale level, what would be a proper pricing construct that would account for uncertainty and flexibility in such a carbon neutral electricity systems? The key challenge is to design the proper pricing mechanism as an information exchange between the independent system operator and the individual agents. Here, agents refers to both generators, traditional demand, as well as new emerging technologies such as energy storage and prosumer aggregation. The scientific challenge here is, while trying to observe optimizing the expected utility of the ISO, how do you design the information exchange in P without knowledge of the underlying states, model, and utilities of individual decision makers? In itself, it is a very hard problem. With certain assumptions, one could design a set of distributed look-ahead mechanisms that would allow for a vector of price, not only for now, but also for the near future, as a means of approximating that societal optimal in the theoretical setting. There is a great need to single out a market for the electric vehicle storage, given the potential of disrupting technologies in electric vehicles. We could see a significant amount of such mobile batteries roaming around the grid. So how do you design a proper architecture for the electric vehicle charging so that it is both a schedulable and also can serve as a reliability services to the grid in extreme situations becomes very, very important. Here, there's opportunities for innovations, both in the new design of market, as well as new mechanisms in a business setting. Let's talk a bit more in detail about a key challenge of utilizing these demand responses for deep flexibility. We have worked on a paper that examining the potential of utilizing a market construct called intertemporal flexibility from potentially such demand response providers in a market. The key idea is that we can utilize the historical data to quantify the lack of ramping situations. Here, ramping refers to this intertemporal flexibility. And that lack of ramping capabilities is then priced and valued by the providers on these intertemporal flexibilities. And one can actually utilize historical data to obtain how much is needed, especially in a scenario where there is a lot of uncertain renewable resources. So one can actually empirically assess such need by using the historical data of the net load, meaning the load minus the renewable generation. And using this green area, it can indicate the probability of ramping shortage occurring. And one can then design proper pricing mechanisms to incentivize the provision of such ramping capabilities from technologies such as energy storage and pumped hydro. And when we have a large amount of demand response in a wholesale level market, there's an issue that needs to be pointed out for today's market design, and that is the issue of revenue inadequacy. So demand response is defined as entities that aggregating demand from individual consumers to participate at wholesale level markets. One of the key issues that we observe in today's market design is that if you allow a standalone demand response provider to participate, the most likely way you treat them would be treating them as a negative generation, right? However, by inducing this negative generation into the system, there will be unavoidably an issue of revenue inadequacy. Namely, there will be not enough money on the table for the ISOs to clear the market. The reason is because this demand response provider is compensated as a way of reducing from a certain baseline, which are not materialized anyway. This then creates this pot of money that is not collected from the load-serving entities' payment to the physical amount of energy produced by generation companies. Therefore, one will have to be aware of such issue and be prepared for some potential solutions, such as a price adder to the electricity in order to balance out this revenue inadequacy. Last, I'd like to refer to you a recent work that we conducted on the retail level markets. The key premise of the retail level market is that while today all the customers are paying the same rate, we are arguing that it is time for us to think of electricity as a service, which is a way to have a fixed customer-specific grid access fee, and on top of that, having a correlation that is based upon the so-called grid friendliness of different prosumers on the grid to determining their price. Here, we're showing you a numerical example in which a grid-friendly customers are actively reducing their demand during the stressed moment of the distribution systems. They ought to be paying at a lower access fee as compared to a grid unfriendly consumer who during the time of stress, if they are they're producing exactly the level of energy that is exacerbating the grid stress levels, then they ought to be paying a higher level of the access fee. By doing so, one would be providing a differentiated incentives in terms of their payment to the grid, and that would effectively avoid the so-called death spiral for the utility business models. And we welcome you to take a look at this paper and share with us any of your thoughts that you might have. Thank you for your attention.